All right, so this question says, what is the greatest prime divisor of 13 factorial minus 12 factorial plus 11 factorial? So a factorial, just to review, is a number times every positive integer less than it. So for example, 5 factorial, well, that's just equal to 5 times 4 times 3 times 2 times 1. 3 factorial is just 3 times 2 times 1. You get the idea. So to answer this question, do we really have to multiply 13 times 12 times 11 times 10 all the way down to 1? And then multiply 12 times 11 times 10 all the way down to 1? No. Yeah, there's probably a much simpler way to do this. So, well, let's think about this. 13 factorial. Well, 13 times 12 times 11 times 10 times 9 all the way down, that's 13 factorial. Now, 12 factorial is 12 times 11 times 10 times 9 all the way to 1. Now, do we notice anything interesting about this? Well, this right here is 12 factorial. So we can say that 13 factorial is just equal to 13 times, well, 12 times 11 times 10 times 9, blah, blah, blah. That's 12 factorial. So it's just 13 times 12 factorial. So now if we're looking at this beginning part, 13 factorial minus 12 factorial. Well, 13 factorial, like we just said, is just equal to 13 times 12 factorial. And so we're subtracting 12 factorial, or just 1 times 12 factorial. So if you have 13 of something and you take away 1, well, you have 12 left. So this just leaves us with 12 factorials left, right? Because you can almost think of that 12 factorial as like a variable, right? Like if we call that x, well, that's 13x minus 1x, which just gives us 12x. Or 12 times 12 factorial. So that's our first part. That's the 13 minus 12 factorial. Now we have to take that 12 times 12 factorial and then add 11 factorial to it. So we can use the same logic here because we know that 11 factorial is part of 12 factorial. 11 factorial, let me move this, is inside of 12 factorial, as we can see right here, right? Because 11 factorial is this section. It's 11 times 10 times 9 times 8 all the way to 1. So we can say 12 factorial is 12 times 11 factorial. So we can rewrite this to become 12 times, well, 12 factorial is just 12 times 11 factorial, or just 144, because that's 12 times 12 times 11 factorial, plus 11 factorial. So if we have 144 of something and we add, well, this is just really 1 times 11 factorial. We add 1 of the same thing, well, that'll leave us with 144 plus 1, 145 of that something. So this leaves us with 145 times 11 factorial. And so now it's looking for the greatest prime divisor of 145 times 11 factorial. So to find this, we're going to have to do the prime factorization of this number. Well, for 11 factorial, we know the greatest prime divisor. I mean, 11 factorial is just 11 times 10 times 9 times 8, blah, blah, blah. So the greatest prime divisor is just going to be the greatest prime number in there. So that's 11. 11 is the greatest prime number in 11 factorial. But let's break down 145 because there could be a bigger prime number inside of that factor. So 145, well, that's equal to 5 times 29, right? Yes, it's 5 times 29. And 29 is actually a prime number, and it's bigger than 11. So our greatest prime divisor is going to be 29.